Question 1 asks us to look at these expressions and circle the ones that are a difference of squares. So here we have A. We look at the first term here, x squared is a perfect square. 81 is a perfect square. We can take the square root of this and get a nice even number. And it is separated by a negative sign. So this is a difference of squares. Looking at B, we can take the square root of 9, which is 3. We can take the square root of x squared, which is x, so it's a perfect square. 16, we can take the square root of that and get a nice even number, so it's a perfect square. However, it's separated by a positive sign, so it does not get to be circled as a difference of squares. Coming over to C, 1 is a perfect square. 49x squared is a perfect square. The square root of 49 is 7, and the square root of x squared is x, so the square root of 49x squared would be 7x, and it is separated by a negative sign, so it's a difference of squares, so we can circle that. Over at D, we can take the square root of 4, which is 2, and the square root of x squared, which is x. However, 10 is not a perfect square, so this is not a difference of squares. So how can we tell what a difference of squares is? Well, we look down at the first term and see if it's a perfect square. We look at the second term. Is it a perfect square? And the operation or the sign in between has to be a subtraction or a negative sign. Foil these binomials. Try and use the formula for the special product difference of squares. So, foil them. X squared, 5 squared, perfect squares, separated by a subtraction sign, x squared minus 25. There's a difference of squares. X squared is a perfect square, 9 squared, perfect squared, separated by a negative sign, so it is a difference of squares. 2x times 2x, 2x squared, 7 times 7, 7 squared, separated by a negative sign. There's our difference of squares. In question 3, we're asked to factor each difference of squares and then check our answers by expanding using FOIL. So we're told right away that these are difference of squares. X squared is a perfect square. 36 is a perfect square, separated by a negative sign. The square root of x squared is x. Square root of 36 is 6. We'll put in our positive. We'll put in our negative. There we have it factored. The square root of 9 is 3. So we'll put our 3's in. The square root of x squared is x. We'll put our x's in. And then we'll have one negative and one positive. Now we're asked to check these using FOIL. So if we've done our job correctly, we should be able to multiply this by this and arrive back at this. So let's check that. X plus 6 times x minus 6, x squared minus 6x plus 6x minus 36. Our negative 6x and positive 6x cancel out, and we're left with x squared minus 36. Over here, we have 3 minus x times 3 plus x. 3 times 3 is 9. Negative my apologies, 3 times x is positive 3x. Negative x times 3 is negative 3x. And negative x times positive x is negative x squared. The positive 3x and the negative 3x cancel out, so we're left with 9 minus x squared. Factor each difference of squares. Well, this is a perfect square. The square root of x squared is x. The square root of 25 is 5, separated by a positive and a negative. Square root of x squared is x. There's our x's. Square root of 16 is 4. There are our 4's. Put one positive and one negative. This one's a little bit more complex. What is the square root of 4y squared? Well, we can look at this in two steps. The square root of 4 is 2, and the square root of y squared is y. So the square root of 4y squared is going to be 2y, and the square root of 36 is 6. So we have our 2y here, our 2y there. Square root of 36 is 6. Put a positive, put a negative. Over again, we have a slightly more complex term here, 9y squared minus 144. Well, the square root of 9 is 3. The square root of y squared is y. So the square root of 9y squared is 3y. Put our 3y here, our 3y there. Our square root of 144 is 12. So we'll put our 12's here. And then we'll put one positive, one negative, and here's our factored form. Question 5 asks us to factor each of the following. You will have to common factor first. So looking at these as they are now, these are not perfect squares. 2x squared is not a perfect square, and 32 is not a perfect square. But if we take the greatest common factor of 2x squared minus 32 and factor it, which is 2, and factor it by 2, we're left with 2 times x squared minus 16. Now, x squared is a perfect square. 16 is a perfect square. So we can use this, what's inside the brackets, we can factor using the difference of squares while just keeping the 2 outside here. So, square root of x squared, x and x. Square root of 16, 4 and 4. Put our positive and our negative here, but don't forget to keep the greatest common factor out here. Question B, once again, 3x squared is not a perfect square. 27 is not a perfect square. But the greatest common factor between 3x squared and negative 27 is 3. So if we first factor it using the greatest common factor, we arrive with 3 bracket x squared minus 9. Once again, what's inside the brackets is a difference of squares. So we can use our difference of squares method to factor what's inside the brackets. Square root of x squared is x. Square root of 9 is 3. Put our positive and our negative, but don't forget to put the greatest common factor on the outside here. Question C, 5y squared minus 20. This is not a perfect square. This is not a perfect square. But the greatest common factor between 5y squared and minus 20 is 5. So we'll factor it using the greatest common factor first. Now, what we have inside the brackets is a difference of squares. Square root of y squared is y. Square root of 4 is 2. And remembering to put our greatest common factor at the beginning. Question C. Again, 8y squared and 18, they are not perfect squares, but the greatest common factor between 8y squared and negative 18 happens to be 2. So we factor it using the greatest common factor. We're left with 4y squared and negative 9 inside the brackets. The terms inside the brackets are perfect squares. 4y squared can be, the square root of 4y squared is 2y. The square root of 9 is 3. So using our difference of square methods, we get the 2y plus 3, 2y minus 3, and remember to put our greatest common factor on the outside. So we have an application. Here we have a blue square. Now without the blue square, the area would simply be x times x. Remember that area is length times width. So the area of the big blue square, without any white square covering it at all, would be x times x. So the area could be stated as x squared. The area of the white square is 6 by 6. We're told that up here. So we could say that the area of the white square is 36. Now, we're asked to factor the binomial to find the expression of the dimensions of an area equal to the remaining area of the large square. The shaded area. So what we want to know is, what is the area of the blue part here? Well, the area of the blue part, if the white square wasn't here, would be x times x, or x squared. The area of the white part is 6 times 6. So the area of the remaining blue part is going to be x squared minus 36. So if the blue part without the white square is x squared, the remaining part is going to be x squared minus the white square, which is 36. So x squared minus 36. And when we factor it, we get x plus 6, x minus 6. So we have a factor, or we have an expression for the area of the blue part. Now we're told that x has a value of 10 centimeters. So all we need to know to know what the actual blue shaded area is to plug this 10 centimeters into x, and it will give us an actual value. So the length is x plus 6. That's 10 plus 6 is 16. The width is x minus 6. That's 10 minus 6 equals 4. So the dimensions are 16 times 4.